In this video, we're going to be talking about the properties of logarithms. Let's start off with what is the inverse of the exponential function with base b? And that answer is a logarithmic function of base b. That's important to know because sometimes when we change things to exponential function, like exponential form, it makes it a lot easier to see what's happening and what we can do, and vice versa. So what are some properties of logarithms? So we're going to let b, m, and n be positive real numbers where b doesn't equal the number 1. And we're going to begin with the product property. So the product property says that if I have the log of base b of m times n, I can rewrite that as the log of base b of m plus the log of base b of n. Our next property is the quotient property, which says that if we have the log base b of m divided by n, we can rewrite that as the log base b of m divided by the log base b of n. And our third property that we're going to be talking about is the power property, which says that if we have the log base b of m raised to the n power, we can rewrite that as n times the log of base b of m. So we're going to do a couple examples here to use these properties so we can see what exactly they do and how it works. So our first example here says to use the properties of logarithms to verify that negative log of 1 over 100 equals the log of 100. So here we're going to be using our power property because we can rewrite our negative log of 1 over 100 as a negative 1 times our log of 1 over 100. Now, the reason why that's important is because really what this is saying is the log of 100, of 100 to the negative 1 power. Or rather, let's look at that a different way. 1 over 100 to the negative 1 power, which means that we're going to be taking this fraction and we're going to be using its reciprocal, right? That gives us the log of 100. And so we've taken our starting piece and verified that we were able to turn it into the log of 100. Let's do it with something that's going to be a little bit easier to think about. So we're going to do a couple others. And in this first one, we're going to write the logarithm in terms of the natural log of 2 and the natural log of 3. So using strictly 2's and 3's. So the properties of logs also work with the natural logs as well because they're logarithms. So because it's asking me specifically to use 2 and 3, what I want to think about is, gosh, how can I split apart a 6 with a 2 and a 3? And that can be done by saying I have a 2 times a 3. Now for this property, we're going to be using the product property, which says that I can rewrite that with a plus sign, right? So again, we're going to be using this property up here, okay? So I can rewrite that, and I can say, all right, I have the natural log of 2 plus the natural log of 3. And I've rewritten it in terms of 2 and 3. If I look at part B, it says the natural log of 2 divided by 27. So here, when I look at that, I'm like, wow, well, the top one's easy, right? Because this is already in terms of a 2, but the 27 isn't. So I want to think, is there any way to get a 2 to turn into a 27? And the answer is no. So then we ask, well, is there any way for a 3 to turn into a 27? And that answer is yes. If I take 3 and I put it to the third power, that will equal 27. So what I really am looking at here is the natural log of 2 over the natural log of 3 to the third power. And from there, I can rewrite that. When I rewrite this, I'm going to be using the quotient property, which means that when they're being divided, I can actually write it as a subtraction problem. So this is going to be the natural log of 2 minus the natural log of 3 to the third. But I'm not done. I can also use the power property, and I can take my exponent here and put it in the front. So this is rewritten as the natural log of 2 minus 3 times the natural log of 3. And now it's been rewritten using my properties in terms of the natural log of 2 and the natural log of 3. So our properties can come in very, very handy and very, very useful.